In this video, I'm going to run through a couple examples of finding the derivative using implicit differentiation. If you haven't worked with implicit differentiation before, this might not be the first video to start with, but we've been covering it for a while, and so we're just running through a couple of review problems here to, so we can check the solutions. So when you do implicit differentiation, you start right out by just taking derivatives. And so we'll do the derivative of this term, 5x squared, and we just write down 10x using our power rule. Now, the expression on the right side of this equation is a composition, and we've used u substitution a lot to deal with those. In this case, u would be y cubed plus 5, and u prime would be 3y squared dy dx. Because remember, y is also a function of x. So that derivative ends up being 2u, which is y cubed plus 5, to the first power, times the u prime, which is 3y squared dy dx. And we can clean this up a little bit. I'm going to multiply this 2 by this 3. And so I have 10x equals, and in fact, let's write the whole 6y in front there. 6y, y cubed plus 5 dy dx. And then to finish this problem off, I really just need to divide by this entire expression here. They're all multiplied by the dy dx, so we just divide them out. And it'll cancel out over on this side. This is 6y times y cubed plus 5. And we'll divide by that over here. And then keep in mind that we can reduce this just a smidge. 2 goes into 6 3 times, 2 goes into 10 5 times. And so I end up with dy over dx equals, in the numerator, 5x. In the denominator, 3y times y cubed plus 5. And I can actually distribute that. And let's make that 3y to the 4th plus 15y. You can either leave it factored with 3 times y cubed plus 5 or multiply it out. But that is our derivative formula. And remember, oftentimes when you do implicit differentiation, you will have x's and y's in the formula, and that's okay. It just means you have to plug in both coordinates for the point where you're looking for that value, that slope value. So this is number 5, and in the next slide, let's take a look at another problem. In problem 10, of course, we have a little trig function thrown in there, and I want to remind you that when we write a trig function and there's just a term that's plugged into the function, sometimes we leave the parentheses off, but they're implied, and so I recommend that you remind yourself to put the parentheses in there. That'll help you realize this is a composition. With implicit differentiation, we just start doing derivatives. The derivative of 5x squared is 10x. The derivative of 3 is 0, so I won't write that down. And then again, over here we have this composition, right? This is our u. So u equals 5y squared. That means u prime is 10y times dy dx. Because y is also a function of x, we have to follow the chain rule. So what I'll do here is I'll write cosine, because that's the derivative of a sine function, cosine of, you leave the u alone, right? It's cosine u times u prime. So cosine u is 5y squared, and then u prime is 10y dy dx. And then to clean this up a little bit, I'm going to multiply that 10y. I'm going to commute these and put the 10y cosine 5y squared, put the 10y in front of the cosine of 5y squared. And then, of course, just like the last example, this is an x here, I'm just going to divide by that entire factor. So I'm going to divide by all of this. So it's gone on this side. That's a squared. And on this side, it's here, right? And finally, I'm going to, we can cancel these 10s. So it looks to me like we should have dy over dx equals x over y cosine of 5y squared. And that should do it for this derivative. Again, we're using implicit differentiation, and once we get the derivatives taken care of, we solve for dy dx. And oftentimes our formula has x's and y's in it. Just to be clear, excuse me, that thing right there is a y. I just want to make sure that looks like a y. Okay, that's just a very brief run through on a couple solutions from the paper that we worked on today. If you have any more questions, we can talk next time we see each other. Good luck. Take care.